Welcome to Forecast Desk, a responsive weather application built to help users search any city, view current conditions, check hourly and 7-day forecasts, review air quality, and plan around weather insights. This project uses plain HTML, CSS, JavaScript modules, chart, JS, Open Weather Map integration, Open Meteor fallback data, browser geolocation, caching, favorites, unit switching, and dynamic weather-based visuals. We are now on the main weather dashboard. At the top, the user sees the Forecast Desk brand and temperature controls for Celsius and Fahrenheit. The selected unit is saved in local storage. When the user switches between Celsius and Fahrenheit, the app updates the unit buttons, stores the preference, and redraws the weather data using the selected unit. The search section is the main entry point. The user can type a city name, use current location, view recent searches, clear search history, and select saved places. Now we type a city name into the search field. After the user enters at least 2 characters, the app waits briefly and then searches for city suggestions. This debounce prevents unnecessary API calls while the user is still typing. The location service sends the query to the weather API service. If an Open Weather Map API key is configured, it uses Open Weather Map geocoding. If not, or if fallback mode is active, it uses the Open Meteor geocoding API. The suggestions list shows matching locations with city, state, and country details. Now we select a suggested city. The app closes the suggestions panel, stores the selected location, places the city name in the search box, and starts loading weather data. While loading, the interface shows skeleton placeholders for current weather, details, insights, hourly forecast, daily forecast, and air quality. Behind the scenes, the app requests current weather, forecast data, and air pollution data at the same time. If Open Weather Map is active, the app calls the current weather endpoint, forecast endpoint, and air pollution endpoint using the selected latitude and longitude. If the Open Weather Map key is missing or invalid, the app switches to fallback behavior. It uses Open Meteor forecast data and maps Open Meteor weather codes into Open Weather style weather descriptions and icon codes. This makes the app usable even without a configured Open Weather Map key, while still supporting the full Open Weather Map flow when credentials are present. The Weather API service also caches responses in session storage. Each cache entry has a time to live of 10 minutes. If the same request is made again before the cache expires, the app returns cached data instead of making another network call. After the data loads, the current weather panel appears. The current panel shows the city name, country, temperature, weather description, feels like temperature, weather icon, and a short human-readable summary. It also shows humidity, wind speed and direction, pressure, sunrise, sunset, and visibility. The app formats temperatures based on the selected unit. Wind speed appears in kilometers per hour for metric mode and miles per hour for imperial mode. Next, the air quality panel appears. When air quality data is available, the panel shows the AQI level, a label such as good, fair, moderate, poor, or very poor, and supporting pollutant values such as PM2.5, PM10, ozone, and nitrogen dioxide. If air quality data is unavailable, the panel clearly says that air quality data is unavailable for this location. Now let us look at the planning insights. The insights are calculated locally from current conditions, hourly forecast, daily forecast, and air quality. The app calculates a comfort score by considering temperature, humidity, wind speed, rain chance, and air quality. A higher score means better outdoor comfort. The rain plan insight tells the user whether to carry an umbrella based on peak rain chance and expected rain amount. The clothing insight suggests light clothing, comfortable daily wear, or a jacket based on temperature. The commute insight warns the user if visibility is low or rain chance is high. These insights turn raw weather values into practical guidance. Next, the details grid shows individual condition cards. The details include humidity, wind, pressure, visibility, feels like temperature, and UV index. UV index is marked unavailable when the current API plan does not provide it. Each card includes a value and a short explanation, such as high humidity feels muggy, stable pressure pattern, or clear viewing distance. Now we move to the next 24 hours section. The hourly row shows the next forecast slots. Each card includes time, weather icon, temperature, and rain probability. The app prepares these hourly items from the forecast list. It converts temperatures, formats local time using the location time zone offset, reads rain probability, and includes icon and description data. Next, we look at the temperature trend chart. This chart is rendered with chart.js. It uses the hourly forecast labels and temperature values to draw a line chart. When the user changes units, the chart is destroyed and recreated with the correct Celsius or Fahrenheit labels. Now we look at the precipitation chart. This chart uses the daily forecast data and displays rain amount for the next several days as a bar chart. Next, we move to the 7-day forecast. The day forecast groups the forecast list by local date. For each day, the app calculates minimum temperature, maximum temperature, peak rain probability, total rain amount, and a representative weather condition near midday. Each day card shows the day name, date, icon, description, temperature range, and rain chance. When the user expands a day, the app shows the forecast slots for that day, including time, icon, temperature, and rain chance. Now let us save the city. When the user selects Save City, the app toggles the current location to Favorites list. Favorites are stored in memory for the session and shown as clickable chips. If the city is already saved, the button changes to Saved. Selecting it again removes the city from saved places. Recent searches are also tracked during the session. When a city loads successfully, the app adds it to recent searches and keeps only the latest set of search chips. Now we select Refresh. Refresh reloads the current location with Force mode. This bypasses cached weather responses and requests fresh data. Now we select Copy Summary. The app builds a short weather summary using city name, temperature, weather description, feels like temperature, humidity, and wind speed. It copies that summary to the clipboard when browser permission allows it. If clipboard access is unavailable, it falls back to a text selection method or shows the summary as a status message. The Open Map action opens Google Maps for the selected latitude and longitude. Now let us use current location. When the user selects Use My Location, the location service requests browser geolocation permission. If permission is granted, the app reads latitude and longitude, then tries reverse geocoding to find a readable place name. If reverse geocoding fails, it still uses the coordinates as current location. If permission is denied, the app shows a helpful message asking the user to enable location access or search manually. The app also monitors online and offline status. When the browser goes offline, an offline banner appears. Cached data can still be shown where available. If a network request fails while offline and no usable cache exists, the app shows a clear error state. The interface also responds to the current weather condition. After weather data loads, the renderer applies a body class based on clear, cloudy, rainy, snowy, stormy, or misty conditions. It also considers day and night using sunrise and sunset times. This changes the visual atmosphere of the page, making the dashboard feel connected to the actual forecast. Behind the scenes, the app is organized into focused modules. The Weather API service handles open weather map requests, fallback requests, error mapping, caching, weather code conversion, and API response normalization. The location service handles city search, browser geolocation, reverse geocoding, and normalized location labels. The cache manager handles session weather cache, recent searches, favorites, and local unit preferences. The UI renderer handles start state, loading state, error state, suggestions, recent searches, favorites, current weather, details, insights, hourly forecast, daily forecast, air quality, map links, and weather background classes. The chart manager handles the temperature line chart and precipitation bar chart. And that is Forecast Desk, a complete weather dashboard for searching cities, using current location, switching units, saving places, reviewing current conditions, checking air quality, reading planning insights, and exploring hourly and 7-day forecasts. It combines practical weather data with caching, fallback APIs, responsive rendering, and visual charts for a complete user experience. Thank you for watching.